Welcome back, everybody. Today we are going to talk about Chapter 1, Section 1, Variables and Expressions. As you look at the top of your book, you will notice that this chapter, this section, is broken down into two objectives. All right, and you'll see that at the top of all new sections, they'll have every objective listed with a number next to it. And you'll notice as you go through the book that this gray number 1 coincides with this gray number 1, where they actually teach you or talk to you about this objective. And if we scroll through, you'll see after that there's an example, a couple that they do for you, and two that they want you to try on your own. And as we turn the page, you'll see that objective 2 has its own little section. It's numbered, so you know exactly, all right, now we're learning something new. Okay, some information about it, some examples that they did for you to look at, and then a few for you to try. And then this section has a real world section, which would be cover one of the two objectives. If there's more objectives, it'll probably cover a few of them. All right, so let's get started on the lesson today. All right. Again, it's Chapter 1, Section 1, Variables and Expressions. You'll find this on pages 5 through 9 of your book. If you're using your online version at home, that's fine. Or if you brought your book home, you'll know where to look. Okay. And just really quickly, let's take a look back at, again, if you just enter in the page number and hit enter, that will tell you, or that'll take you right to where you want to start. All right, now we can get started. So, objective 1. So we're going to write a verbal expression. So we're going to take something written in algebra and we're going to convert it to words. All right. To do that, though, we want some background information, and I'd like you to define these words. So what is an algebraic expression? It's any expression that contains a variable. All right. Usually, and we'll talk about terms in a second, but an algebraic expression, I'll use my pen here, could be something as simple as x, or maybe 3x, 3 times x. Or we could even throw some addition or subtraction in there. We could do 3x plus 4. All right. Now, what is a term? A term, each of these are terms actually. So x is a term, 3x is a term, and actually 3x plus 4 is 2 terms. All right. So a term is anything, a variable and a constant, connected by either multiplication or division. Okay. So again, it could be x, it could be 4x, it could be x over 4. That is one term. A variable term contains a variable. A constant term is just a number. So if we're looking at the number 4 here, that would be a constant term. All right. And explain the parts of a multiplication expression. Simply that you need to understand that if I had, let's say, let me go back to the pen here. Let's say 7x. This is a multiplication expression, 7 times x. The 7 and the x are factors. Okay, and when I do multiply these together, that is a product. All right, so 7 and x are factors. When I do multiply, let's say I thought x was 4 or x equals 4. 7 times 4 is 28. That is the product. All right, so the end result's the product. Each of these parts are factors. And then draw and label the parts to a power. What that'll look like, we'll make a power here. So let's say, let's do x to the 4th power. And we can use all numbers here, or we could even use x to the nth power. All right. The bottom here, this is called the base. It's hard to write with the mouse, but I think I can do it. That is the base. And then the little number here, as you probably already know, is the exponent. I'll change colors so we can see that. Not too bad. So again, the bigger bottom portion is the base. The smaller portion at the top is called the exponent, and the whole thing is called the power. Okay, so this is a power, that's a base, that's an exponent. So these are parts of a power. All right, hope that helps. Now let's get into it. So example 1, we're going to take this right here and we are going to write a verbal expression. So we're going to take this 3, the x cubed, or x to the third power, however you want to write that, and then minus 14. Okay, I kind of wrote it a slightly little different than you think you might write it, but I actually said 14 less than 3 times, because when there's a space here, 3 times x cubed. So that would be how you'd write this. You could write 3 times x cubed minus 14. You could do that. But I wanted to show you this because oftentimes when we see the less than, that actually happens second. All right. So you'll see this, a constant less than some variable term, 3x cubed or 2x squared or 5x to the third, whatever. That'll be written first, and then you're going to write your subtraction sign, and then you'll write the constant. All right, so that is probably as tough as these examples get, is a problem that uses the wording less than. All right, and here's our other one. We have 1/4, where it's being multiplied by x to the 4th power. We're adding the product 4 times y divided by 5. So that's pretty much how I'm going to write this. 1/4 times x to the 4th power plus 4 times y divided by 5. Looks a little trickier, but this one you can, because it's an addition, you can pretty much write it straightforward. So not too bad. Now what I'd like you to do is I would like you to try sorry about that, pushed the wrong button. I'd like you to try the guided practice 1A and 1B. I believe it's on page 5. If you don't have your book with you, I have them right here. So hit pause, and I want you to write out these 2 answers. And I'll see you in a second. All right. Now, we'll check those tomorrow when you come into class. So objective 2. So we're going to take something that's verbal, and we're going to write an algebraic expression. All right. Now, you don't have to copy this down. This is at the top of page 6. Maybe put a sticky note on it in your book, or just make a mental note that this, or even write it on your paper, that this chart is on page 6. So these are some of the words or phrases that we will use to describe addition. More than, sum, plus, increased by, added to. Subtraction, less than, we just talked about that. Subtracted from. Difference, decreased by, and minus. This will probably be the one you use the most, but you'll probably see this one as far as you actually have to do problems with the less than. Multiplication is a product, multiplied by, times, of, that's a big one. Of is often hidden in story problems, and you have to pick out that of means multiplication. Is usually means equals. Not that that's on here. And then division, quotient of or divided by. So again, page 6, top of it, take a look. Now, again, we're kind of starting out right away with a less than. So it's 5 less than 3 times a number. We just talked about that less than kind of happening second. So we're actually going to be subtracting 5 by whatever comes next. So 3 times a number. That's 3x, 3 times a number, or 3n, whatever letter you want to use, minus 5. All right, and then a number x more than 5. More than means addition, so x plus 5. And then 1/2 the base times the height. There's 2 ways to write this. We could write it as 1/2 b h, 1/2 times base times height. Or if you understand that this is a numerator and base and height are a numerator, I can multiply these 3 together. 1 times b times h is just bh, so it would be bh divided by 2. Taking half of a number is the same, or multiplying a number by half is the same as dividing by 2. So a couple ways that might look. All right. So what I'd like you to do now is try 2a and 2b on page 6. If you don't have your book with you, here's what they look like. Pause it, write the answers for these 2, and I'll see you in a little bit. And then moving on, I'd like you to read this example. Okay, read the problem, read their explanation and their answer, and then I want you to try number 3. The only thing I would tell you is the directions say write an algebraic expression that represents the cost of the order. I want you to think of this as the cost of making these things. All right. So the cost of the pastry per pastry and the cost for coffee. All right. So you might use P and C for coffee for those. All right. I hope this helps, and I will see you guys tomorrow.